Hi, everyone. Thank you for joining us for today's session with Wallaroo.ai, getting your AI models to the production start line. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. This session is recorded. It will be available to view on demand in 24 to 48 hours. I'll now turn it over to our presenters for introductions. Thank you.
Hi, everyone. Thank you again for taking time out of your busy day to spend this session with us in the Microsoft Reactor. I really appreciate it. I know there's a lot of things that command your time, and do appreciate you taking, making the decision to join us here. And so, great to have you in this session. And what we'll be doing in this topic today is, if you've seen some of the previous Reactor sessions, we've done where we talk about, deploying models to edge, we talk about orchestration, we talk about observability, just some of the conversations we've been having with practitioners in the community like yourselves is that, folks are saying, we have these different kind of model frameworks and, in pre-production, how do we get this to the production start line, and how do we make that easy for ourselves and minimize the amount of lifting and overhead and delays that that normally takes place. And so that's what we're going to try and do today. So we'll talk through getting to the production start line, and it'll give us a chance to see how we look at it from our perspective, but I'm sure there's a lot of different experiences out there that you have, and so we'd love to get that dialogue and feedback and experiences from the field as well. So we'll kick off with some introductions. We'll go through some of the challenges that data scientists and MLEs experience in that pre-production stage to get to the production start line. We'll talk about an ideal scenario. It's not the ideal scenario. This is how we see it as we work with customers in getting into AI production, and great opportunity again for folks to give us your experiences and let us know how you sort of deal with this. And then to show that we always try and be practical in these sessions and get into the the code part of it. And my colleague Ankush will go through a demo and show what this will look like in action as well. So then we'll summary up at the end. We have opportunity at the end for Q&A, but we also have the Q&A line. We have one of our colleagues there helping answer questions. So if you do have something, by all means, post it in the chat, and we'll try and get to it as we go through the session itself. So just a quick introduction for myself. If you haven't seen our previous ones, my name is Martin Bald. I'm the Senior AI Community Manager at Wallaroo.ai. I've been very, very fortunate in my career. I've spent over 2 decades in the tech industry, mainly with Microsoft, and I've enjoyed a number of roles: pre-sales, technical with customers, partners, and then also in the Canadian sub, but also at corporate in Microsoft as well. And the most recent role I had before I left the company was in DevRel, and it was probably, it was the most enjoyable time of my career, where I got to work with, developers, data scientists, and MLEs such as yourself, and seeing how you tackle problems and issues and overcome those with technology and code and solutions. And it never ceased to amaze me how folks like yourselves, apply technology in a business case, and then also for code for social good as well. So great to have you on board. We also have Aishwarya here with us today. Aishwarya, would you like to introduce yourself, please?
Hi everyone, I'm Aishwarya Srinivasan. I'm part of the Microsoft for Startups. I'm a senior AI advisor for startups in this team. I'm helping out startups with building their tech stack and optimizing it on Microsoft Azure. And a lot of my time is spent on helping the startups build it using OpenAI services. So that's what I'm doing. I have my background in being a data scientist in companies like Google and IBM. And I absolutely like working in this space, and with startups especially, it is such a fast paced innovation stride that we're going with. So it absolutely impresses me the way they're going about it, and what Wallaroo is doing is just incredible, Martin. Your entire like tech stack on helping people go from development to deployment, and that to such a fast rate, it only calls out that how fast we can do experimentation and go to market.
Thanks, Shreya. Great to see you again. I know we've worked with you in the past, so always wonderful to work with you on these sessions and topics. And my colleague Ankush, can you introduce yourself?
Absolutely. Hi, everyone. My name is Ankush Garg. I'm the Technical Solutions Manager here at Wallaroo. And my role at Wallaroo entails working with our customers and making them successful with the Wallaroo product. I've been in the AI space for about 7 years, first as a product manager in retail, managing analytics and AI projects, and then doing more hands-on data science and ML engineering work at early stage startups. Throughout this journey, I've noticed that getting the models built and ready for deployment is a relatively easy task compared to getting the models into production. I've been very fortunate here to be at Wallaroo, helping companies do exactly that, getting the models into production, some of which we'll cover here today. So thank you for having me. Very, very excited to be here.
Awesome. Thanks, Ankush. Great to have you here, my friend. So before we go in, I think Aishwarya was great and so talking a little bit about, who we are and, what we do. But this slide sort of gives a sense of, where exactly do we fit in that production AI lifecycle. So we are a production AI platform, and we, help companies go from that prototyping, that pre-development stage into production, regardless of what data scientist or ML environment you develop and prototype your models on. But today we will focus on Azure ML, and so we deploy to any cloud, and we also deploy to uh, you know on premises as well, and also edge also. And so we have the full capabilities of allowing you to sort of decentralize those endpoints and push models to the deployment endpoint of your choice, but then also have this centralized management capability for MLOps to manage those models, deploy, serve, run through observability from wherever they're running, and then also orchestrate. As you scale models, you have a chance to then workflow those models and scale them out, so you can run them in batch mode certain times of the day and so on. And so that's who we are, right? We help companies get those models from that pre-production into production stage. For this specific session today, we'll focus on what we have inside this red box, and so we talk about getting to that AI production start line, specifically as you go through evaluation into model deployment. And so you might be working on your own, depending on the size of the organization. You might be, the lone data scientist. There might be other ML engineers at play that you collaborate with. And it's important to make sure that we bring those folks together in that AI ops process and not create silos within an organization that can cause delay, that can fracture the productivity, and then also lead to delays and not really realizing the potential of the models that everybody spends so much time on. But the one challenge that data scientists face today in that deployment process is that they're expected to learn and know all those tools. They're expected to be that full stack engineer, working not just with the models such as PyTorch, sklearn and TensorFlow, but then also understand that infrastructure element as well, setting up those clusters, managing those resources and everything that goes into them, and also taking those models from different development processes. There might be different departments working in models in PyTorch, but there might be other departments or folks working in TensorFlow. So how do you bring that all together, quickly and in a streamlined fashion, so that you can then, push them out to production and get some of that bandwidth back again, so that you can then focus on managing them, those models in production, making sure that they're returning the value that is intended, but then also going back and into that life cycle and working on other models that you want to scale out into that production space. And so what we're trying to do today is to then take a look at, okay, what's an ideal scenario? How can we help folks manage that whole process of having to understand that full stack and all the elements and variables that go into that? And so, the way that we approach it, and, as I talked about at the beginning, great to get feedback. This is just how, we see it. But essentially what we want to do is enable data scientists and MLEs to help them be self-sufficient in that model deployment and scaling that process. Also with minimal coding. You can throw as much code as you want at things, but that takes time. You got to review things and so on. And we want to really simplify that. We want to make it easy, efficient, and flexible for the folks that are working in that space. And through flexibility, giving you that capability to work with any model that you're familiar and comfortable with, whether it be, PyTorch, TensorFlow, XGBoost, etc. The other element that's very important, as you probably saw from the previous slide, is that there are colleagues in the IT ops and DevOps space that are running a myriad of different elements within the infrastructure and architecture of the organization. And so what also slows things down is a dependency to make requests of them. That leads to additional production overhead. It leads to delays in getting those models into production. And so if we give that self-service capability to you as a data scientist and an MLE to quickly streamline those models, get them into production faster, then that hopefully gives more bandwidth back to you and other folks, working on these models, so that you can then, strive to get more value from them. So that's the scenario that we've set up. And so we want to see what this looks like in action itself. And so I'll hand it over to Ankush and Aishwarya now, where Ankush will take us through the demo and tee this up, and they'll discuss this process. Ankush?
Thanks, Martin. And thank you to Aishwarya for co-hosting the event with us. If we can go back to the slide, Martin's slide. So we noticed a gap in the industry where data scientists and machine learning engineers have to upskill and learn tools like Docker and Kubernetes and specific deployment frameworks in order to bring different models to production. This means that data scientists and ML engineers are spending precious time focusing on creating Docker files, managing dependencies and environments, as opposed to spending time improving the performance of the model and the output of the model. So we saw this as a problem in the industry and followed an approach to standardize how different models get packaged and thereafter deployed. This circumvents the need to learn Docker and any specific deployment framework and gives the space and time back to the data scientists and ML engineers to improving the model. So in this example today, we'll showcase how we can take multiple models, scikit-learn, TensorFlow, and package them up for deployment. And we'll also show, after the models have been packaged, how we deploy them using Wallaroo, and how we can deploy it for specifically cloud or even edge device without having to ever manage any infrastructure. In this example, we'll focus on a regression problem with the house price prediction use case. Given a set of features about a house, we're estimating its cost. So I'll share my screen, and we can take a look at some code. Okay, I'm here in Azure ML, and I have a notebook here called Upload Models. And right here in the directory, I have a few models. The TensorFlow model, which essentially is trained and zipped up, and the XGBoost model. This is exactly where a data scientist would pick up the flow after models have been trained and validated and are ready to be deployed to production. So here I have some imports. I'm importing the Wallaroo SDK and some Wallaroo specific different things that I would need. This SDK, this Wallaroo SDK, will allow me to connect with the Wallaroo instance that is currently running. So Wallaroo is an installed software, and which this SDK, Wallaroo is an installed software in your Kubernetes environment, and this Wallaroo SDK will allow us to communicate with that instance. I have some more imports here, and the very first cell that we run here is the client, Wallaroo client. Essentially, this is the step that authenticates this particular notebook or environment that I'm running in with the Wallaroo instance. After I run that, I get a client object back, and now I can start to start to upload models, deploy pipelines, so on and so forth. The very first thing I'll do here is create a workspace, and I'm calling it House Price Prediction Azure ML Workspace. And you can think of workspaces as a delineation of your entire available environment, which allows you to upload the models and deploy the pipelines in that particular workspace. I've chosen to delineate it by the use case, but it could also very well be by delineation could be by teams or by use cases or different projects. So we run the cell, we've authenticated, we've got the workspace, and we set that workspace as our current workspace. And this is where we will be uploading our models to. So for the first example, we are uploading a deep learning model, a TensorFlow model. Essentially, I'm using the upload method from the client. I'm passing in the model name, the model path, the zipped up model path, and I'm defining the framework itself. Framework here is TensorFlow, and when I click that, the model is uploaded. It's available in the registry, and we're ready to continue to bring this model to production. Here, I'm defining a particular pipeline, and I'm calling that a TensorFlow house price prediction pipeline. Pipeline, you could think of them as the execution of the model we just uploaded. So I'm defining a deployment configuration here, which essentially is what resources I'd want to give to this particular pipeline once it's deployed. I'm giving it 1 CPU, 1 replica count, and 2 gigabytes of memory. And I build the particular pipeline with the pipeline name, add the model step, the TensorFlow model that we just uploaded up above, and call deploy by passing in the deployment configuration that we defined also. And when we run that cell, great, the pipeline is deployed, and we can check the status of that, and the pipeline is running right now. So that was really quick to getting to that, getting the pipeline to production. We can test out how that looks. We'll get some sample data. we'll convert that sample data point, just one data point, to a data frame, and then we can call pipeline.infer to get an output. So at this point, I decided to use pipeline.infer method in order to make an inference to the pipeline that we just deployed, the TensorFlow pipeline that we just deployed. We have a few other ways you can make inferences. This is in the notebook, but alongside, we also, if I call pipeline.url, it will expose the endpoint and the service that we've stood up behind the scenes for this particular pipeline. Please notice that we didn't have to worry about any infrastructure or any Docker files or anything like that here. And right out of the box, after deploying the pipeline, we were able to deploy it and receive an endpoint that we can start to integrate into our applications.
Ankush, I had a few questions like while we were going through this particular part. One, you mentioned about how we are uploading a particular model, right? So I'm curious to understand, like once you have uploaded a particular model, let's say over a period of time, I have iterations on model version, right? Or I want to like have different versions of the model just to capture different set of audience or like do an A/B test. How would that reside in your upload framework, and like how would that translate into this pipeline that you're explaining?
Yeah, absolutely. Wonderful question, Ashwarya. So if there are different versions of the model, you can upload them, similarly by this upload command that we just shared. New versions of the pipeline of the model will just, be all available in the registry. They'll all be available, and we can take a look at, which specific version of the model we want to add to the pipeline and deploy. So that's one thing. And then you also had a question about A/B testing. So we have, as a part of the pipeline deployment, we also have, the shadow deployment and A/B deployment services available that will allow us to pass in multiple versions of the same model, or completely different models that we can deploy as a part of a single pipeline. And when the inference hits, we can route the traffic 60% to 40% based on however we want to configure it. So that part is available as well.
Oh, that's wonderful. That I'm sure that's going to be like super helpful for people who are trying to like build these testing pipelines for themselves. Another follow up, like I'm curious to understand if are there any other frameworks that you're supporting at this point in time?
Yeah, wonderful question. I just showed TensorFlow. We have support for many common data science frameworks. We support TensorFlow, Keras, XGBoost, sklearn, Onyx, the usual data science frameworks. We also have integrations with Hugging Face. So all of the common Hugging Face pipelines are also represented as frameworks within Wallaroo. This includes examples like text summarization or text generation, or even audio transcription, for example. And lastly, we also have this idea of custom frameworks, which we'll show an example of in a little bit, but that could essentially be any Python code, right? It could be pre-processing code, or it could be post-processing code, or even esoteric framework that is not one of the ones I listed. That could be included in the framework custom as well. Yeah, so tons available.
That's wonderful. Thank you so much. I'll let you continue.
Wonderful. Okay, so we just saw an example of uploading a TensorFlow model and deploying a pipeline very quickly and seeing some results out of that. And we also took a look at the pipeline URL that we got out of deploying this particular pipeline. We'll move on to the next example that I want to show, is uploading an XGBoost model. This is if you notice, slightly different, but very much the same, right? I'm still using the upload command here. The only difference here is the framework. This is an XGBoost trained model. So I pass in the XGBoost framework, and then two other things, input and output schema. This is also defined because we are containerizing the XGBoost model automatically, and at runtime we're letting the model know and the image know what the input and output schema would be for this. So after doing that and uploading the model with XGBoost model name and XGBoost model path, we can deploy that. And this deployment would take about 10 minutes, under 10 minutes, because it's being containerized. And once it's uploaded, it's ready to go. And much like we did above, we can take this XGBoost model, add it to a pipeline, and deploy that particular pipeline. Next thing I want to show is what I was alluding to earlier, is the custom inference pipelines. This essentially, the framework here is custom framework, and I have the model here, which I'll dig into real quick. The input and the output schema looks exactly the same as we saw with XGBoost. The thing to note here is that the custom inferencing pipelines are very, very flexible. Like I mentioned, it could be, your pre-processing code that could be executed as a pipeline, or deployed as a pipeline rather. It could be post-processing, or it could be any esoteric framework that I want to bring in and deploy it as a pipeline. In this particular example, even though I have a framework, XGBoost, available here, I'm essentially wrapping the XGBoost model in some Python code and adding some post-processing logic on top of it, which I'll show in a second, just to showcase the functionality a little bit. So XGBoost model under the hood, it doesn't need to be XGBoost, it could be any model, and I'm adding some post-processing step afterwards. But the upload command remains the same, with custom as being the only difference. So let me show that real quick. So this is the custom pipeline folder, which I've zipped up, and that's the path that I'm showcasing. In the custom pipeline folder, I have three things. I have the artifacts folder, which have the model itself. I have a main.py and a requirements.txt file. And this could be any library. When we containerize this and upload it, we'll set up the environment for this image and container to run. And we can take a look at the main.py. I collapse all these so that it's not confusing. Here, again, this is any random, any custom Python code. So I have some imports here, and then these are Wallaroo specific imports that I have. And two main things to note: I have the inference and the inference builder, and I'm defining two separate objects here that inherit from inference builder and inference respectively. Let's take a look at inference builder. Essentially, the purpose of the inference builder is when an inference comes, when the model is running in production, the inference builder will load the model up. Here, like I mentioned, I am importing and loading up the XGBoost model. And that's the inference builder's job. The inference here is when that inference comes and the model is loaded, we are calling the predict function underneath the hood. And what it does is it's calling the model's predict function, right? So model itself.model.predict, we're getting some results, and we're post-processing those results. And the post-process is essentially all the predictions that we're getting, we're capping the values to be 150,000, just the value that I picked just to showcase the functionality a little bit. This is, right, so I loaded up the XGBoost model, and then as a post-processing step, I'm capping the value to 150,000. And that's pretty much it. Once I have this file ready to go with the correct imports and the correct structure, I can zip it up, and I've named it custom pipeline here. And when we go back to the notebook, let me collapse this, we can upload this model. Once that is uploaded, much like before, as a TensorFlow pipeline, we can deploy this pipeline. Pipeline custom, we're building the pipeline and adding the model step. This time, the custom model step. We have the same deployment configuration, and we're able to deploy that pipeline. And we can take the same data point from earlier that we have and call pipeline.infer on this particular pipeline. And the result here, as we would expect, is 150,000 based on the post-processing step that we included in the custom inference pipeline. If we can switch back to the slides. To summarize, what we've done here is we took a few different models with different frameworks, and we packaged them up and uploaded them. We packaged them up by uploading using the Wallaroo commands. And once the models were uploaded, we were able to deploy pipelines to the cloud, and without ever having to worry about Docker files, environments, either of those, or infrastructure. Just all we had to do was give the pipeline specific resources as a deployment configuration, and the model and the pipeline were deployed. Back to you, Martin.
Thanks, Ankush, Aishwarya. Aishwarya, was there anything else you wanted to add, or before I sort of move on?
Yeah, I'm just curious to understand if there is a different methodology that you're using in case if a model is being deployed on edge.
Yeah, wonderful question. For right now, we just did a pipeline.deploy, as we saw, and that deploys the model to the cloud. And publishing and deploying the model to the edge on edge devices is extremely simple. Much like the deploy command, we have a publish command that is exposed on the pipeline itself, and we can simply say pipeline.publish and pass in a deployment configuration. And what that does is it brings in all of the necessary artifacts that we need, the pipeline, the model, all of that, packages it together and pushes it to a container registry. Now, we can pull that image from wherever we have Docker, or we also have Kubernetes support. So either of those, wherever we can pull that image down from, we can run this published pipeline on the edge device.
That's amazing. That's absolutely amazing, Gush. I wanted to see the demo that you showed us, right? Like you were walking us through the notebook. Is there a place that the viewers can access it after the session? Like, is there like a public facing notebook, or is it part of a blog that people can access?
Yeah, wonderful question. I'll let Martin take that one.
Awesome. Yeah, no, good question. Very timely. Yeah, we saw a great question there from Ahelia in the chat queue, and he was asking for the tutorial that's in the notebook that we're showing right now. And yeah, I'm sure you know, like myself, I learn by doing, other folks do, and it's great to get kind of hands-on. But yeah, we posted the link to the tutorial for those custom model pipelines that Anku showed. But also, if you go to docs.wallaroo.ai, we have a host of other tutorials there that go through that auto packaging example that he showed at the beginning. For XGBoost, sklearn, PyTorch, etc. So you can actually go through them, as well as a bunch of other, use case type tutorials. We have, CV, LLMs, etc. up there. We also have workshops also. So, those provide the notebooks, but, we take some of the code out so you can actually go through and learn a bit more by doing some coding within those sort of self-guided workshops. And to run those tutorials and workshops, we have, for the community, we have our free community edition. It doesn't expire, so you can just, download it. You can install it into your Azure tenant if you like, but there's also GitHub code spaces. If you're not aware of this, it's a really great, resource. Folks get 60 hours free, cloud time a month. And so you can install the community edition into GitHub code spaces. It takes like 2-3 minutes to do that. And we've got some videos on our YouTube site that'll kind of walk you through that. But yeah, you can, run through, just get yourself set up on the community edition and then go through all these tutorials and workshops that we have on our docs.wallaroo.ai site. We also on the Azure Marketplace have a number of free inference servers. Again, these things take less than 5 minutes to, spark up. And we have about 9 different VMs for common AI use cases. So we have, ResNet, YOLO, Llama, Hugging Face, Summarizer, all on x64 GPU, and we have another one on AMD as well. And so if you want to sort of try them, you can. We also, as I mentioned at the beginning, this is how we look at it. We would love to find out and get feedback from yourselves in the community. I'm sure, Ishwari, you've had some experiences in that hurdle in getting to production as well. So please, my email is at the bottom, and you can follow me or reach out to me via LinkedIn as well. Do we have any other questions in the queue that we can answer? It's a good opportunity now.
I think this is wonderful, Martin. Thanks a lot, Ankush. This was super helpful, and I'm sure like a lot of the people who are viewing this will find it very helpful, and most of all, find a lot of the code that you shared reusable. So I think you've done a great favor to a lot of developers out there.
Thanks. There's a question from Sean. For all those auto-generated infra, how do we manage the cost optimization, security, including compliance and transparency of those things? And Kush, you want to take that one?
Yeah, if I understand it correctly, for the auto-generated infrastructure, I think that was the question. Can you repeat the question again, Martin?
Yeah, it says for all those auto-generated infra, in quotes, how do we manage cost optimization, security, including compliance, and transparency of those things?
Yeah, I think the answer here is initially when we
so the one thing that while Ankush is going through that, one thing that we do is part of our. Sorry, go ahead. Oh, I think you broke up there. I'll continue, but the one thing that is in the DNA of our product is that we optimize the compute inference. So the product is developed on a high compute engine, and so we help manage cost optimization in a few ways. One is that for some models, you don't have to go GPU. You can do GPU mix of x64 or even x64 as well. So the compute engine has the capability to manage that architecture of your choosing, and so that's one way to help reduce costs. The other way is the fast inferencing. So our inferencing and deployment is super fast. That also helps reduce costs as well. And as Ankush mentioned, with the model registry, and we have full audit trail available also to help companies with compliance, depending on which industry they're in as well. We also, you have access to that. So within, the product, you have, the collaborative element where you can invite other people into, your workspace. And so you're going to have that transparency and collaborate with other folks on, those model deployments. And so those are just, a few ways in which, we address, the cost situation and compliance, for companies. Yeah, I'd love to, have more chat around that. If you want to, please reach out to me. There was one other question quickly. From Helly, it goes, does this work with LLMs? Yeah, so yes, it does. Oh, the marketplace inference service that we do, we have LLMs there. And we also have tutorials on the LLMs that will run in the community edition also as well. So yeah, we're going to add more and more to this as these models come online and are available to folks. But yeah, there's all these open source models. We're working on getting those tutorials up as well.
Yeah, and just to add, we're constantly working with our customers as well on deploying open source models like llamas or even Whisper models. So we see that a lot. And yes, it works with our frameworks.
Fantastic. I don't see any questions in the queue. Shwari, is there anything you'd like to add, or are you good?
No, I think you covered pretty much a lot of things. So I'm curious to check out the notebook myself. Thank you so much.
Yeah, thanks again for joining us, Shwari. As I said at the beginning, it's always great to work with you and engage with you on these things, and super happy that you're with Microsoft as well, and looking forward to continuing that work. I want a quick thank you to Ankush as well. He is a customer-facing engineer, and so spending the time to prep and ramp up on this, is really very much appreciated. And also we have our colleague Bob, who is also one of our sales engineers on the Q&A chat as well, and really appreciate Bob. And then last but not least, the Reactor team. A lot of work and effort goes into the Reactor team in the background to make these things work, and so we really appreciate everyone's time and effort for these events, and look forward to the recording. And as I said, we'd love to hear from you on this, and if there's any other topics that you'd like to see in future sessions, by all means let us know, and we'll see what we can do. Thank you.
Thank you, everyone.